Number 20. The 12 centimeter long rod in figure 23.11 moves at 4 meters per second. What is the strength of the magnetic field if a 95 volt EMF is induced? All right, so this one is fairly straightforward. We're going to use this formula over here. This talks about the induced EMF, how it is a function of the external magnetic field strength multiplied by the length of the rod that's moving, multiplied then by the velocity of that moving rod. And this is all happening because as this rod moves, there is a changing then magnetic flux happening through this particular area because the area is changing. In other words, if you look at the formula up here, there is a changing magnetic flux because the area is changing. And therefore, when we have a changing flux over a certain amount of time, there's an induced EMF, blah, blah, blah. That's all, okay? So we can now simply calculate this by using that formula that the induced EMF, the induced EMF is going to be equal to the external magnetic field strength multiplied by the length of the rod multiplied by the velocity. If I want to find the strength of that external now magnetic field, I just got to simply now divide out then the length and the velocity, right? So it'll be EMF all over then the length times the velocity. Let's make sure we have all of our standard units. The voltage they told us was 95. Remember, that's what EMF is, how it's measured in volts. The length there is 12 centimeters, but you don't need that in meters, so that's 0.12. And then the velocity, they gave it to us in meters per second, so that's just a 4. You're simply going to now plug and chug. So this is going to be 95 divided by 0.12 times 4. All right, and it works out to be about 198 Tesla. Okay, and that takes care of that, guys. So thanks for tuning in. Hopefully that helps, and I'll see you in the next problem. Take care.